from New York. It's Weird Trick Mafia. We have Andrew here in town as well. Super awesome.
New York City.
Yep.
What's up?
This is my apartment. It's pretty cool.
I'm here for the chaos engineering day. Been getting a little chaotic. I need more chaos in my life. Clearly, you could tell from my hair.
Nice.
So you've been busy. You say busy lately. I'm not even sure we can go through everything you've done since the last time we talked. But the one thing I kind of wanted to start with, and we'll work back from there, maybe episode by episode, is you got pretty excited about the open compute thing that just happened.
Yeah, that was super fun. I mean, I really enjoyed meeting people there and hanging out.
So why don't you tell people about the event that you went to, and then we'll get into some of the stuff you saw and got excited about.
Nice, yeah. So Open Compute, if you didn't know, it's kind of a new project or set of projects that came out of Facebook for all their hardware that's running on their servers.
It's been out for a while, like a few years, right? It's not that new.
No, it's been out for a while, for sure. Because they're already doing like this thing where they give refurbished servers away and stuff like that.
They're like, we're done with these.
Yeah, which is cool, because like I think I'm gonna get
toys.
Yeah, it's dope. So it's all their hardware, and then it's also like this community of open source firmware as well that runs on the hardware. And so there's all these specs and designs for like boards and different designs for boards that do different things like GPUs, stuff like that.
What was the scale of the conference, right? So I think people sort of have a sense of how many people are going to KubeCon now.
Yeah.
What kind of attendees did we see at the Open Compute?
I would say like maybe like anywhere from 800 to 1200. It seemed like.
Respectable.
Yeah. It's pretty good.
There's plenty of room at the bottom.
Yeah.
So what did you see that got excited, and what kind of stuff?
So yeah, the first day, like I spent a lot of time with the open firmware community because they had just a room for doing stuff. And that was nice because like the community is still super small. So it was very personable, and it was like nice to see what kind of all the companies are doing. And then also like everyone was giving feedback to the chip vendors there, like Intel and ARM. AMD wasn't there, which is interesting. So it's cool to see like open firmware pushing.
So what was that feedback? And like, what was the pushback?
Yeah, so the firmware people are like, can we please stop giving us, your firmware in the chips? Because like they end up shipping things like, their runtime services, all the stuff that kind of like make sure that your firmware is running right. And it's like, for, Google, Facebook, like all these companies, it's like they want to control that shit in the kernel and they want to control it in user space. So it gets in the way. And so like most of the conversation was around like the firmware doing less and being more open, basically.
So that is a general theme. And then there's probably like more specific things that each one did, or.
Yeah. So even IBM was there, and they've had like open firmware with like Power for a long time. So it was interesting to get their take because they were less. So a lot of like the open source firmware community that was there is working on like Linux Boot, which is this open firmware project that uses Linux, because it's like Linux has already been vetted as far as being like secure by other people, and like if you're already using it, if you're already using it in your stack, it means that you trust it to a certain level. So like, why not also trust it in the firmware versus some other bullshit? So like they were all kind of talking, and like that stuff, like having that stuff like currently on all the chips, like it wraps binary blobs for like Intel or ARM. And so getting rid of those binary blobs and a lot of that logic in there would be awesome, to the extent that then you could have way more control over knowing what's running. So that was like kind of the main focus.
So we can't get rid of them. You can't like get rid of them anyway, or they just didn't want to do that. So
the vendors don't want to do that because that's their proprietary code.
No, but like once you have the control of the physical hardware, you can't get rid of it.
And there's a ton of problems too, in that like now all these kind of chip vendors are shipping these things. Intel's is called BootGuard, and ARM's is called something else that I've forgotten. But so BootGuard actually makes it so that like Intel only holds the keys for changing the firmware. So you actually cannot then run open source firmware on that chip, which like completely negates the entire point of this entire ecosystem. Like then you don't have any control, and you just brick the board. Although there's been like a vulnerability that Trammell Hudson found, who is like, he's been doing all this firmware stuff. So he found that actually if you get the chips to go into kind of the error screen where it can't boot, and then you try to recreate and it can't find that screen, it will just go and boot. Yeah, so it's bad. Like the whole thing is bad. It's like it's a terrible feature because it prevents open firmware. But then also it's like it's not even doing its job of securing it. So like, why do we have it?
So maybe, I mean, educate me here. What are the things you can change? If you can't change this firmware, then what is the firmware work that these companies do? How do they take their work and put it onto the hardware? And then also, what does Open Compute cover in terms of the rest of the sort of peripherals and devices and storage and networking, or is it really just about the chips, the CPUs?
Yeah, so it does wrap like the binary blobs for like Linux boot wraps these binary blobs, and like the binary blobs expose this interface, which I forgot the name of, but it's like this kind of open interface that like, you know, it interacts with. So the problem is though, like these vendors are kind of like shoving more into that interface and more into kind of the hidden stuff. And it would be nice if all that was open as well, so that like when you have a bug in kind of that interface layer, you know that it's actually in the chip itself versus, you know, the stuff that you own.
You can't tell the difference between what came as part of the hardware and what came as part of this bundle that you can't change.
Yes, totally. So it's hard to debug, and it's hard to like, when you have, you know, servers at scale, you would like some more transparency into what's happening. But it is nice that you can get like from this interface, which seems like the lowest possible interface of dealing with these chips, to, you know, booting in open like firmware, which is cool.
So the firmware, because doesn't Open Compute do some stuff with storage too, or is there like there's like other parts of the Open Compute that's
so there's all
chips,
these
right?
SIGs, and so I just happen to be most interested in the firmware, so I went to that. But there are a bunch of other SIGs, and like you can sign up on the mailing list and like get involved with those, and like all the communities are so small that like you'll see the mailing lists are not very active. I'm like on them all, just like kind of lurking.
Because there's no mail.
Yeah, there's like no mail, so I'm just like, I'll just continue to just like, it's like maybe once a week I see a mail or something. It's weird.
Then this firmware group you met, you mentioned it is small. What's the number? Like how many people are we talking about?
There was probably like 15 or 20 in the room, so it was nice. Like when we all got lunch, we were just like nerding out about the Apollo 11 movie, because everyone kind of seemed to be space nerds as well. And I think like a few of them were like, I'm going to go see this movie tonight. So that was cool.
Fantastic. Yeah. Then the rest of the show, so the firmware was what percent of it was kind of like one meeting, right?
Yeah, that was just one meeting. So then we like kind of like went around to like some talks and stuff like that, and then also like kind of checked out the vendors, because like even in the expo area, like Facebook had all their actual like servers and stuff, which was dope.
Right, I saw pictures that got posted.
Yeah,
you posted some stuff.
So their stuff is like just super. It's super clean.
It looks really futuristic. It looks like designed, right? Oh,
I mean, they're like super designed, and like they made everything like nice, and you can see it come out in the way that they'll talk about it. So like I kept asking this one guy to pull out this one rack because I wanted to look at it, and he was like, by the third time I think he was a little bit annoyed, but every single other time he was like, there's this one part and one part, and then like it's very nice in that like like the DIMMs are alternating colors, so you can kind of like the DIMM slots like put in the memory. I don't know. There's like little attention to detail.
So that's kind of the user experience. So you can tell which DIMM you're in.
Totally. I mean, they put a lot of thought into it. Like they really did. It's nice.
So you mentioned how many people are at the conference, and then there's this small firmware group, and there's probably a bunch of other SIGs like that. What were the other things or the other talks that you saw that were exciting, either in the booths or in the talks?
Yeah, so I had to like leave early so I didn't get to see all the talks, but I've been meaning to look them up online. But like Ron Minnick, who does like all the firmware stuff at Google, he's like super brilliant and into like firmware security. So his talk looks like amazing, and I need to check it out. But they do all their firmware in Go, so they'll have like Linux boot into like this U-boot, which is kind of like a root file system in Go. That's all user space Go stuff. So it's like cool because like firmware, if you like think about it. Like most of the time it's like people either writing like assembly or like some shitty C, but it's like now you can use like the tools that you like have at your disposal, like Linux and bash scripts and like Go and stuff like that, to write firmware, which is crazy and cool. And it like opens it up to like a whole level of engineers and stuff.
A whole level of people that don't know what they're doing.
Yeah, which is great. It's really good admiral.
Fantastic. So then what do you think that evolves into, or I mean, was it just you're just there as a spectator to casually check this out, or you have like some ideas about some things you want to play with?
I mean, I was just honestly checking it out. I hope to, get a Intel chip that I know like doesn't have boot card on it, and I can, flash Linux boot onto it. And also like Ron from Google said that he's gonna like hopefully set up a class where we can all learn. So I'll probably like go out for that because that sounds awesome. Yeah, I mean, honestly, I just think it's super cool, and I feel like it's heading the right direction if the chip vendors also like pull more and more into open, although it seems to be kind of going the other way.
And what do you think their incentive would be to do one or the other? Like why would it doesn't help them sell more to have it? Like they sell the physical thing, so I don't understand their incentive to lock down more of it personally.
I don't know. I mean, it honestly seemed like from speaking to the vendors that they understood that now, like hearing that like nobody wants like runtime services or SMM or like dumb shit in there that like just gets in the way. It seemed like they understood, but it also is like, I know from working at big companies, it's hard to then give feedback to the teams to understand where these people are coming from.
We're adding value with our, with our thing that no one wants. What else did one of the things I always thought was fascinating, this is like slightly different topic, but sort of related. If you start thinking about how to manage lots of big server farms, then one of the things that I was always frustrated with is how poorly and how inconsistent all the lights out management stuff was across all the different vendors. And you get to these points where when something doesn't work, you don't know if it's like something you did wrong or it's just like a bug in their thing, and then you like retry it again and it works. And then I'm just curious if you see, or because I'm not following the OpenQB stuff that closely right now, anything interesting happening to not like when you start to think about, to me, like if you start to think about if you have racks and racks of servers and you have some API driven way to kind of manage images and pixie boot those images onto those machines at will, that looks suspiciously like a cloud.
Yeah, no, totally.
And you can start to do some interesting things on the bare metal in your data center or whatever. So I was just wondering if that's sort of stuff you're playing with or looking at too.
Yeah, so like the whole overall like nice thing here is that like if you control like a large percentage of the firmware, then you do know what's going wrong in what device. So then it's like, I was even talking with Facebook people, and so all their stuff is like super modular. So like you don't need to like unscrew anything. They have all these kind of like touch things where like you take out a DIMM or like you can take out a GPU just by pulling the handle. So it's like they know that when something is like messed up in the hardware, they know where it's coming from. So if it's not the CPU, they'll just take out a DIMM and replace it. Like, so if you have all the management software controlling all the firmware and everything's kind of like clean from the stack up, you can just get pinged that, this DIMM in this one, cage is bad. And then you just go replace the DIMM. Or if it's like the CPU, then they just like, they pull out the DIMMs, they like throw away the board, and then they like put those DIMMs in a new one, then they shove it back in. So it's like when you get that granular scale and you know like for certain that like this thing in this board is bad, it's like so much easier to replace shit.
So this is sort of a different topic, but related. At what level would you want to replace it? Like you have to imagine at the scale, any of these people you're talking about, Facebook, Google, whatever, that there's some high probability that right now there's a DIMM failing.
Yeah.
Do you want to go respond to the random DIMMs that are failing, or do you want to think about building resilience into it, and what kind of granularity are you going to replace things? Like, are you going to wait till there's like one DIMM, or are you going to wait till it's like, oh, let's pull this whole rack and like refresh it or whatever?
I mean, I think it's up to the team. So like with Facebook, I mean, they clearly are very pedantic about like each and everything. But then like at Microsoft, like I heard, and I don't even know if this is true or not, but I heard from several people that like when something goes wrong, they just wait for like a lot to fail, and then they just like ship in like new racks. So it's like if you care about it at the rack level, you can care about it.
I guess you're right. Like it's just an operational decision that you make based on the context and resources of whatever you're doing.
Totally.
So what else?
Yeah, so I mean, their hardware was super cool, and also like they like have so many different specs. Like I was trying to look at all the different specs, and like it's like unwieldy. So I am actually gonna get like what they do is they have like refurbs of their old servers, so I'm gonna get some of those.
So these are the Facebook specific versions of their Evolution as they kind of rethink their servers?
Yeah, so like if you got a refurb now, it would probably be like 5 or something years old because they have now entirely new specs. So kind of like the specs that they like make, like they're probably running them in production like way before that. Almost.
Yeah, right.
So yeah, it's interesting to see kind of how it evolves because like there's the ones that are refurbs, then there's the ones that I saw at their booth, and then you'd have to like imagine that I bet like there's whole different things that are actually running.
So I just have this thought about how kind of the cycles of open source commits work. So it's like I'm a developer and I have this thing I want to do, or I'm fixing some issue, and I make a commit, and now that's everyone can see that, and it's part of the workflow and pull request for this issue. I wonder, like, what's the actual cadence and time cycle in the work that they're doing to design this hardware, and like what actually comes, because like you write code, you delete it, write code, you delete it, and you get a thing, and then you commit it. So I'm wondering like how they do those cycles, because it's not as easy as just recompiling a thing and like making the unit test, right? So I'm wondering what that kind of lifecycle cadence looks like for their software, or I mean their hardware development.
Yeah, I mean I have no idea. Like I mean I'm sure that like they have a totally different perspective on computing than I do, because like they could probably like I was hearing from multiple people like predicting like that the cost of RAMs go up, which right now like it's on the downfall, right?
Yeah, but for a while it was scarce.
Yeah. So like almost knowing that and then making boards around that, I'm sure that there's like a whole kind of life cycle where people think about this whole world in it versus like and then they have to think about like how long it takes like Quanta to make it, or if Quanta can make their specs.
And that brings up another interesting point, because for the most part, there's none of the people we're talking about can really fab their own stuff.
Yeah.
Right. So there's this other cycle where it's like you have this thing, you want to see it, like it takes someone else working on it before you actually see
it. Totally. I mean, I have a feeling that like Quanta loves Facebook though, for like the amount of boards that I saw. I'm like, this is a good relationship, I'm sure. And their boards are like super nice, like they're so clean, and it's just like they have the Quanta logo on every single one, so they're getting like free marketing.
Well, if people start doing more open compute fabrication, they're probably going to do the same.
Yeah.
The same people.
Oh, for sure.
And so it's like,
it makes a lot of sense. Like Quanta had a booth and they were talking to people that entire time.
Interesting. So what are you going to do with all this knowledge you learned, or what are you thinking about? What would be interesting to either play with or innovate, or is there next level thing?
With the refurbs, like you can get like servers on the penny because they sell them super cheap. So like they have these like kind of mini stacks where you have just like 3 of these node servers, because like the original designs for Facebook servers, they're not like a 1U. It's like these like kind of square shaped things, and then you get these bigger fans. So like it's not as
so that brings up another interesting point. When you start thinking about what it takes to run these in a data center, what kind of power requirements and what kind of cooling requirements do you have to run each of these different variations or versions of the hardware?
Yeah, so like the power is totally different. So like if I got just one server and I wanted to run it like in my apartment, I need like this dev server box that like connects into the power bus in the back. Okay. Because like the cool thing about all of these is that the second that you shove it into the racks are like made so that the power bus connects into the bus at the back of
the physical connection to the power is in the rack.
And you can like feel it when you like pull it in and pull it out. I mean, it was like really cool. I was like, you got to pull it in and pull it out because it's like super dope.
Because you feel it like locked into the.
You feel it lock in, and you're like, this is a nice design, because like you don't have to like be like, oh, I got to plug in the fucking thing. So then like so there's that, and then like there will be like a power box in the middle that like controls all the power in the rack, and then like just like 2 kind of things fall out from there, and then you need to plug them in your data center. So it's clean.
So what data center do you have that you're going to run?
It's got to be like a custom data center. Like, I mean, or like, they also like give all the specs for their layouts and shit.
So can you run it in your apartment?
Oh, so I could, yeah.
Right.
You just need the like right converter for the bus.
So the right converter is sort of like a single slot thing to slide it in.
Yeah.
To get the power.
And like, so IT Renew, which is this company that like does all the refurbs, they have like a mini rack where you can do it with 3 and then plug it in. Okay. Or they have like kind of these like dev converter things where like as long as you cover up the power thing and not catch on fire, like you're probably okay.
And what about heat? Is that something anyone you guys?
So like how hot it gets?
It gets hot. Right?
Yeah. So like you can tell in some of the specs like how Facebook lays out their servers.
I mean, some of the things that are most fascinating, I don't know if you read James Hamilton's blog or any of these like optimizations in the data center for power and cooling that have happened over the last decade or two. But it's just fascinating to see how much innovation and thought has gone into, as you get these scaled out data centers, getting the heat away from them, right? Because they will basically melt.
Oh, for sure.
At some point. So probably at the level of 3 in a thing, and you're in the corner of this apartment, it'd be fine. But.
Yeah, no, like when you get the big ones, like you can tell the way that Facebook lays out their entire data center. They also open sourced literally the data center layouts.
Right.
So cool.
I remember seeing some of those when people were excited about when they first came out.
Yeah.
And so that's also, I mean, I didn't go there, so I don't know exactly all the stuff you saw, but when you think about all the things it takes to deliver this, you know, at scale, like, what you got to pour concrete, right? Like someone has.
No, yeah, like that's like Facebook probably pours concrete for their own data centers. Google does too. Like you're gonna be like in the top like of the spectrum, which is not like normal people. That is not like the norm at all, for sure. But it is cool the scale.
I mean, someone has to do it.
Yeah.
I just want to SSH at some point. Are we still allowed to SSH?
I don't know. I should have asked them. I doubt. Like they said that their management software is all proprietary and closed source, which is funny because that's like the stuff that like.
Which people said this?
Facebook.
Oh, okay.
That all their management software, but like I have to imagine that at some point you can SSH into a box, but like also if you're running.
I was kind of making a joke because people say like you shouldn't SSH,
yeah.
right? And I've said that too. So then I mean, basically that's kind of like their Borg or whatever. They're like tools for managing whatever they're doing.
Yeah. And like I assume that it's like almost like a Kubernetes, but with, you know, power management and also, you know, knowing when there's a hardware problem, failure, like everything that Kubernetes is missing for the people who want to run on bare metal.
Well, if you look at how Kubernetes was born, like Borg,
it makes sense.
That has that stuff. Right?
Yeah, it totally makes sense.
What else is there? Is that feels about like an episode, or is there kind of a thing that we should tell people that we want to think about next, or?
No, I mean that was pretty good for me. I'll try to think of something else that I did.
I mean, you did a bunch of stuff, right? Like most of these things are blog posts. You even had a blog post about the open compute stuff, right?
Yes, I did. Totally.
So we can put that in the notes so people can go read that. But I think it's just a fascinating time to be alive and watching all this stuff. On the bottom, like everyone's excited about all the open compute stuff. On the top of the stack, everyone's relicensing because they're like afraid.
Yeah, actually, that is interesting. That I don't think that the cloud providers could play that same game down here. I mean, I don't know.
I mean, in some ways, they all are independently, and Facebook's sort of playing a gambit, and that's how to. I mean, this is my read of when the original open compute stuff got started, because I'm sure the innovations that have happened inside of Google, like whatever anyone thinks is their competitive advantage, they're not sharing.
Yeah.
Right. So at the point where Facebook has decided this is not differentiating for us to do this work, and we can get more from a community benefiting and like being in that cycle with other people doing the innovation, then maybe we have a chance. Because I would wager that there's some like next level stuff that's going on inside of the Googles and the Facebook, I mean the Googles and Amazons or whatever, that isn't necessarily coming back into the open part of it.
Totally, that makes a lot of sense. Totally.
So till next time.
Yep. We'll see you.
Weird tricks.
Yeah.
Cheers.